Okay, so beginning of part 3 here. The coordinates 7, -5 are on the terminal side of an angle, and that's saying that's on a circle. So just imagine a circle centered at the origin there. 7, -5, that's down here. So I'll draw in the circle here. So on that circle, down in this quadrant, we have a point. Let's make it blue. 7, -5, somewhere about there. So we'll make a triangle out of that, and that's what we're going to work with. So again, we always draw up to the x-axis. That's always where we work. So if I know here that this coordinate is 7, -5, oops, that makes this 7, that makes this -5. Well, in order to do all 6 trig values, I have to know what the hypotenuse is. So I'm going to use my Pythagorean theorem. 7 squared plus, I'm just going to write 5 squared. I could write -5, but when I square it, it's going to become positive anyways. Let's just call it h squared for hypotenuse. So 49 plus 25. Well, 49 plus 25 is 74. And so I'm going to do the square root of 74, and that's going to give me h. And you can try to simplify that. It does not simplify. 74 is only divisible by 2 and 37. 37's prime. There's nowhere we can go to simplify that. So I've got this hypotenuse now that I am aware of is the square root of 74. So now, here's the angle. I don't even have to know what the angle is, but now I can find all 6 of my trig values. I can find the sine of that angle by doing the opposite over the hypotenuse. And then we're going to rationalize. So I get -5 times the square root of 74 divided by 74, and that's as far as that one goes. And we'll do the cosine. I'll put that over here. The cosine of this angle, whatever the angle is going to be the adjacent over the hypotenuse. So I have 7 over the square root of 74, which again we're going to rationalize by multiplying just like we did here. I'm going to get this, and 74 is not divisible by 7. 7's prime, so that's as far as that one goes. Let's do tangent of the angle. That's going to be opposite over adjacent, -5/7. That one stays just like that. No rationalizing needed. And now we'll do the inverse functions, and we'll do them in red. So we're going to do the cosecant. That's going to be the inverse of sine. So instead of inversing this, I'm going to inverse this thing. And it's going to become negative square root of 74 on top and 7 on the bottom, and I'm done. The secant of the angle, that's the inverse of cosine. So if I invert this, I get the square root of 74 over 7. I'm all done. And the cotangent is the inverse of this guy, the reciprocal, so I'm going to have -7/5. So just by knowing the coordinates of a point on that circle, you can figure out, even though we don't know what the angle is, and we'll talk later on how to do that. You may remember the inverse button, but that's not what this asks. We don't have to know that angle. All we have to know is this location and the 3 sides of this triangle, and we can go ahead and find all 6 trig values, trig function values, with ease. Okay, let's go on here. Multiples of 90. The multiples of 90, or pi over 2 radians, are are the locations actually on the y or the x-axis. So I've highlighted them here by showing you their coordinates. We're using the unit circle here. Unit circle meaning the radius is 1. So that's how I know this point up here is 0, 1. This is -1, 0. This is 0, -1. And this is 1, 0. Well, any point on this circle can be triangulated like this. So I have an x-coordinate, a y-coordinate, and the hypotenuse, which is the radius of the circle, which is 1. Well, if I take this point and I start sliding it up along the circle towards this point up here, what's going to happen is I'm going to start to become, the triangle is going to change to a taller looking triangle like this. Okay, but this little guy right here is going to be the x, this tall guy here is going to be the y. Well, what that's eventually going to reach is the y value is eventually going to become 1 up here. Okay, and then you can just picture how that slides around the triangle like that. Well, let me get rid of these so we don't get too much stuff here and this doesn't start to look confusing to you, if it's not already confusing. So sine, cosine, tangent, we remember sine is the opposite over the hypotenuse. Well, because we're using the unit circle here, that's going to be the y-coordinate over 1, which is just y. And that's nice. That's going to allow us to work at these 4 locations on the x and y axis, these green coordinates here that I highlighted. Cosine is the adjacent over the hypotenuse, which is x over 1. That's just going to be the x-coordinate. And the tangent, here's where it comes in, makes it more obvious. The tangent is the opposite over the adjacent, y over x. Remember before I told you that tangent is equal to, let me highlight it here for you, y over x, that's the sine over the cosine. So it's worth noting right now that the tangent of an angle is equal to the sine of that angle divided by the cosine of that angle. This will come in handy later on. This is one of our identities that we're going to be using. So, a couple things here before I get into the calculation of these values. The domain, you know, we can put in any value that we want. We can find the sine, the cosine, and the tangent, for that matter, of these. But the domain of sine and cosine, any real number can be put in. But the range, the values that we get out, we're going to notice that the sine value, the biggest it could get is this coordinate of 1. And then the triangle starts to become shorter again as I start dragging that point around. And it comes down here to -1. So the sine values, the function values, have to be between -1 and +1. Well, the same thing for the cosine, because cosine is the value of x. If I drag this point here, this is as big as I can make x on this circle, and that coordinate's going to be 1. The smallest I can make x is when I drag the point over to here and I get -1. So I have a very important property here that the sine and cosine values both are going to be between -1 and +1 always. All right, so what we can use here, let me put some separation here in this. We want you to be able to do the sine of something like, let's say, pi over 2. The cosine of pi over 2. And the tangent of pi over 2. Pi over 2, hopefully that pops right in your head. That's this location right up here. Okay, because it's pi divided by 2. Pi is 180, don't forget. Well, the sine is the y value. So the sine of that value is 1. The cosine is the x value. What's the x value up here? 0. So the cosine is going to equal 0. And the tangent is the y over the x. Well, up here, what's 1 divided by 0? You can't do that. 1 divided by 0 is undefined. So let me do a quick demonstration of this. Here, these angles are in radian form, so I'm making sure I'm in radians there. And we'll type in the sine of pi divided by 2. We'll show you that we get 1. We'll type in the cosine of pi over 2. We'll show you we get 0. And we'll type in the tangent of pi over 2. And we'll show you that we get undefined. Error. Doesn't work. You can't divide by 0. You say go to, and it brings you to here. All right, so that is how you're going to find the sine, the cosine, and the tangent, or the secant, cosecant, and cotangent of any multiple of 90 degrees. It could be 90, it could be 180, or pi radians. Here, the sine would be 0, the cosine would be -1, the tangent would equal 0, because 0 divided by -1 is 0. At 270 degrees, or what we call 1, 2, 3 pi over 2 down here, radians, the sine would be -1, the cosine would be 0, the tangent would once again be undefined because you're doing -1 divided by 0. Then when you get up here to 360 degrees, or 2 pi radians, the sine is 0, the cosine is 1, the tangent is 0 divided by 1, which is 0. And you can verify those on your calculator. Just make sure that you're in the correct mode, radian versus degree, and you can quickly determine those, all using the unit circle. So this will become memory. The more you use it, the more it'll just make sense to you. If you know, like I said, if you use it enough, eventually you won't have to think much about this. It'll just be there. These are periodic functions. Sine, cosine, and tangent repeat. The values we're going to see, especially once we graph these things, it'll become clear. But periodic functions are functions that have a repeated set of function values for a repeated period of values within that domain. The smallest amount that must be added to the function in order to create a repeated set of function values is called the period. Well, sine, for instance, will repeat every time we go around the circle. We'll come back to the same point, and it'll go over again. So the period is going to be 2 pi. Same thing for cosine. We're going to notice the cosine is going to go to 0, -1, 0, +1. Then it's going to cycle over again. 0, -1, 0, +1. Sine, the y values, goes 1, 0, -1, 0, and then it goes again, 1, 0, -1, 0. It just keeps on repeating itself over and over and over. So it could be 360, it could be 720, it could be however many times around the circle, it's going to keep on repeating it. So we call those periodic functions. And we're going to graph those, and we'll do all kinds of cool stuff with them as the chapter goes on. So you'll see the word periodic. I want you to know that that is referring to the fact that the values that we get, if we keep going around the circle and around the circle and around the circle, we're just going to get the same thing over and over and over and over. And that's what the reference to periodic means. The period, back to this one more time, the period refers to how far do we have to go before we get the same pattern repeating over again. Well, the period is 2 pi for this function of sine and cosine, because I have to go around the circle once, and then I'll notice that the values just repeat themselves. And we will begin the next video with this problem.